when we get the prime factorization of a number, we're going to write it one of two ways. We're going to either use the standard form, which is just writing out all the factors. What's the trick to standard form, though? What do we need to make sure we do?
Order.
They need to make sure they're in the right order. Do we go from smallest to biggest or biggest to smallest?
Smallest to biggest.
Smallest to biggest. So we start with the smallest factors, and then we go to the biggest. With exponential form, we go smallest to biggest still, but if we have factors that are repeated, we can use exponents. Exactly. So if we had a bunch of 2's multiplied together, we can just write it 2 to some power, and then we don't have to write all those 2's out. All right. So we're gonna start both of these by using a what? A factor tree, right? So what two numbers can we multiply together to get 80? 8 and 10. Anytime a number ends in 0, what do you know has to go into it? 10, right? And so we know it's going to be 10 times something, and if we just take that 0 off, then we're left with the 8. So when we divide by 10, we just basically take a 0 off. So we know it's going to be 8 times 10, or 10 times 8. Does it matter which order we write it? No. It could be 10 times 8, or it could be 8 times 10. They're both 40. So when we're doing the factor tree, I'm sorry, they're both 80. When we're doing the factor tree, it doesn't matter which order. Okay? Let me ask this. Could you have done it a different way?
Yeah.
Yeah. You could have done 2 times 40, right? Or you could have done 20 times 4. Okay? There's a lot of different ways to do it. Does that mean that this is the only right way to do it? No. Any of those other ways would be okay. As long as you do everything correctly, you get all the way to the end, you're going to get all the same factors. And as long as we write them in the correct order, we'll be good. All right, so how about that 10? How does a 10 factor? 2 times 5, okay. And then how about the 2? How does that factor? There's only one way to do it, right? Yeah, so the only way to factor a 2 is 2 times 1. Why would we not do 2 times 1? Why should we not do something like this? Yeah, it's just going to keep going and going and going, right? So anytime we get to a point where that's the only thing we can do, we're going to circle it. All right, how about the 5? How does that factor? Yeah, same thing. The only thing that goes into 5 would be 5 times 1, but we never want to, really we never want to use the 1. So if the only thing we can factor it is the number and 1, then we're done with it. We'll circle it. All right, how about the 8? We still need to go with the 8, right? Okay, 8 could be 2 times 4. And we already said 2 is done, right? What do we call a number that cannot factor anymore? That's a prime number. What do we call a number that can factor? Composite, right? So 2 is a prime number, but 4 is not prime. It is composite because 4 is 2 times 2. Okay? Now, the reason I circle these, there's 2 reasons. One is I know that I'm done, so I can move over to another branch of the tree and keep going from there. The other is now that I'm done with everything, I want to go through and just check off everything that I circled and make sure I get it in my factorization. All right, so the first one we're going to do is in standard form. And standard form we said needs to be what order? Least to greatest. So we're going to start with the smallest numbers we have circled here, which would be the 2's. How many 2's do we have? 1, 2, 3, 4 of them. All right, now you don't need to do what I just did. I like to do that though, so that I can make sure that I have everything in my list here, everything that I have circled, make sure I get it in my factorization up here. Okay, so I've got 4 2's, and then the only thing I have left is 5. Okay, keep in mind that when we're factoring numbers, those numbers multiply together to get the number that we started with, so we need to put multiplication in between each of them. Okay? What would happen if I punched this into my calculator? 2 times 2 times 2 times 2 times 5. What would it give me? 80, right? So this is just a way of writing 80, but by multiplying all prime numbers together. All right? And there are important reasons for us to do that. We'll get into those, at least some of them later on. But for now, we just want to make sure we're factoring it so we have all prime numbers, and then we're done. All right, so there's your standard form. How about exponential form? What's that going to look like? Okay, 2 to the 4th power times 5. And what if, since this is exponential form, what if you really wanted to put an exponent on this 5 here? What could you do? Yeah, you could put a 1 there. You don't need to do that. There's no need for it. But if there was an exponent there, it would be a 1. It's kind of like if we have a variable with nothing in front of it, we could put a 1 in front of it. If we have a number with no exponent, you could put a 1 in the exponent. And that just means that there's 1, 5 in our factorization here. And we're done, right? With the 80 at least. So I've got 2 answers there. Got the standard form, got the exponential form. I'm going to box both of them to show that they are my final answers. How about the second one? What can we multiply together to get 4,500? Devin? Okay, that would be one way to do it. I'm not saying that's wrong, but I'm not going to do it that way. So we could do 900 times 5. I like a different way for different reasons, but that is a good one. Moshe, what'd you do?
I said 45 divided by 100.
Okay, I like that. So just like the 80 here ended in a 0, so we know 10 goes into it, since the 4,500 ends in 2 zeros, then we know that 100 goes into it. So we can do 100 times 45. Now, if you did it a different way, like 900 times 5, or what I saw some people do, I'm going to write this down real quick. So we have the 4,500. Some people recognize it ended in a 0, so you do 10 times 450. And then the 450 ends in a 0, so it would be 10 times 45. That's going to give you the same numbers. Okay? I like this way the best, because we get rid of the zeros with one branch, and then we get everything else with the other branch. All right? You don't have to do it any one of these ways. You could do it any way as long as you're using numbers that are correct. So how about the 100? Let's factor that. What do we multiply to get 100, Carl?
10 or 10.
10 times 10, okay.
I have a question.
Each of those 10s can factor, right? In fact, we factored the 10 up here. 10 is what times what?
1 and 10.
Well, 1 and 10, but we're never going to use 1, right? Because if we use 1, we're not getting anything. But 5 and 2. And again, it doesn't matter if you do 2 times 5 or 5 times 2, it's going to give you the same thing. All right, how about the 45?
5 times 9.
5 times 9. All right, we could do 15 times 3, right? Could we do 45 times 1? No, we never want to use the 1. 5 is prime. That cannot factor, but 9 is composite, so we need to keep going. 3 times 3. Now, here's a tree that's a good example of why circling helps. If I'm writing out my standard form here, and I didn't circle these prime numbers, I might forget that this 5 is up here. So by circling the numbers, it just kind of makes it pop out a little bit and make us see that we need to use that also. All right, so we're going to go smallest to biggest. So we're going to start with 2s. How many 2s do we have?
2.
Let's see, 1, 2, 2. Okay. So we have 2 times 2. Then we're going to do 3s. 3, 3. Okay, so we have 2 of those. Do we have any 4s? So we're going least to biggest, least to greatest. Are we ever going to get 4s in a prime factorization?
No, because it's not a prime.
Exactly. 4 is not a prime number, it's a composite number, right? So if we had a 4 in here, we should have factored it and gotten 2 times 2 for that 4. So we're never going to have any 4s. So we go to 5 now. How many 5s do we have?
3.
1, 2, 3 of them, right? So we're going to have times 5, times 5, times 5. And there's your standard form. Again, circling the numbers helps make sure that we get them all. And also, what I did here, crossing them off as I used them, if I go through and just look through and make sure I have everything that's circled crossed off, then I know I got everything in my list. All right, how about the exponential form? What's that going to look like? Okay, 2 squared. I like the squared there. So squared is the same thing as second power, right? So 2 squared times 3 squared times 5 to the third power. What's the other way of saying to the third power? Cubed. So we could read this 2 squared times 3 squared times 5 cubed, or you could say 2 to the second power times 3 to the second power times 5 to the third power. Either way is okay. These are final answers, so what should we do with them? Put a box around them. And again, we've got 2 different answers here. We've got the standard form over here, and we've got the exponential form here.